Hello everyone. We're going to break up learning target number 5 into two sections, okay? And the first one is about Fourier analysis, okay? So we need to understand what happens to a wave, whether it's longitudinal or compressional, when it transitions in between two mediums. Now, if that transition happens not on an angle, if it goes straight into a new medium and then back out again, the wave itself does slow down in the new medium, or speed up, depending on what it is, but it leaves at the same angle and with the original velocity. But something interesting happens when the wave enters a medium at an angle, okay? So we're going to have like medium 1, medium 2, like this might be air and water. And a wave will enter on an angle. Okay, so we'll have a wave enter on an angle. Now this wave could either be reflected or refracted. Okay, if it's reflected, then it will bounce off of that surface at the same angle. Okay, so that would be a reflected wave. That whatever this angle it entered as, it's going to be the same when it leaves. Okay. Now the other thing that might happen is it might be refracted. So it might, instead of continuing and going straight, it might bend this way or it might bend that way. Okay. And so depending on the mediums involved, so instead of it going in straight like that, it might bend. There's not a great angle. Anyways, this refracted, what should we do? We'll just do an R. This angle will be different than the other one, okay? And so I should have drawn it more at an angle, like further in that way. But the angle of the wave is going to change. And that's because of this interaction right here, where part of the wave is in the new medium and part's in the original medium, and the speeds differ because of that. Okay, and so if we have a wave entering this medium here, like let's say we have wave fronts coming in, well, see, we're going to get to a point where the bottom of the wave is in the new medium and the top of the wave is in the old medium. And if this isn't going to travel, if this is going to travel further, then that is because the speeds are different. That's going to cause it to angle once it gets into the new one. And so then we get a new angle of the wave because of that. Okay, so this is a refraction ray, and this is a reflected ray. All right, now, reminder about constructive and destructive interference. When two waves are in phase with one another, then we're going to have constructive interference. Like if we have peaks and peaks, they're going to add together, or if we have troughs and troughs, they'll add together. But if we have a peak and a trough, that would be deconstructive, out of phase, and they end up canceling each other out. So we get this really interesting phenomena. If we have two sound waves that are very similar in frequency but slightly different from one another, there's times when they're in phase, right? When the peaks and the troughs relatively line up, and so we get constructive interference, okay? That the amplitude is now greater because we're in phase. And then slowly it becomes out of phase where the peak is interacting with a trough. And when that happens, they cancel, and so the amplitude gets smaller. And remember, amplitude relates to loudness. So we have, for a moment, a really loud sound, and then a really soft, quiet sound, and then loud, and then soft. And so we get this loud, soft interaction, okay? There's a couple videos that are posted on the same day with the notes. One addresses speed of waves, and then one is an example of a beat where we have two frequencies. And so I want you to make sure you watch those so you can hear this interaction, okay? When we look at two waves and determine if it's constructive and destructive and what that resulting wave will be, that's a Fourier analysis. So if we take this wave and we play this wave at the same time, so we have two waves traveling through the same medium, they're going to interact with one another, and we're going to get some resulting wave because of that, okay? So see, here's the original wave, and then here's the secondary wave. And then our resulting wave here is a combination of both. That when they're both above the origin, we have constructive. When we have the original wave that's above the origin, but the secondary wave is below the origin, we have destructive. Okay? And so notice that it's kind of like a combination of the two. And that's exactly what would happen here, is we have constructive and destructive interference resulting in a wave that's a combination of the original two. Now, if you have one wave that's longer in wavelength and one that's shorter, when you're doing this analysis, what you should see is that the resulting wave has the same general trend as the longer wavelength, but we'll have interactions, constructive and destructive, within that because of the secondary wave. Okay, let's look at this problem. We're going to talk about these two waves interacting with each other. And I'm going to take a moment. I'm going to draw in an origin line for both of these. It'll be helpful for us to determine if it's constructive or destructive, because we want to know, is the wave above the origin or below the origin? Okay. And so see, I've drawn that first origin line, and then I'm going to draw the second one. Okay. So when our waves at the same moment, this direction, when they're both above the origin or both below the origin, we're going to have constructive interference. But when they are above and below, then we'll have destructive. Okay, so they both start at the origin. I'm going to draw my resulting wave on the bigger one. That'll be easier. And then notice for our smaller wavelength here, we have a peak. So if I go directly above that, the first primary wave is also above the origin. So they're both above the origin at this point. And so instead of destructive, we're going to have constructive interference, right? We'll take this part of the wave and it will be added to that part of the wave. Okay, so I've just drawn a point that my resulting wave is going to be up there at this point. Okay, but now let's look at this point. This is below the origin, and if I go straight up from that, my primary wave is above the origin, and then we have below the origin, so we're going to have destructive. Okay, so I'm going to take this, and it's going to be, we're going to subtract it from the original wave. And then again here, this is above the origin, and if I go directly above that, it's also above the origin, so I'm going to add those together. Yeah. And then here, I'm below the origin, and this is above the origin, so it's destructive somewhere down in there. Now, similar idea, but now our primary wave, the first one, is below the origin. So right here, I'm above the origin and I'm below the origin. So instead of adding them together below, they're going to subtract from one another. Okay? And then this is below and that's below. So I'm going to add those together. Okay? And then this is above and the other one's below, and then below and below, and then they end at the origin. Okay, now that I've recognized each of my spots there, I'm going to connect my wave. So we start at the origin, we'll go up, and we'll go, oh, I went too far. And we'll go down. Okay, so I'm just going to connect all the dots, creating peaks and troughs at the places that I've recognized and calculated. Okay, and so then that's my resulting wave. Now, I want you to notice that the resulting wave has the same general trend as the original, right? It goes up and then it goes down, and then we have all these up and down interactions because of the secondary wave there. Okay. On the next video, we'll go in and look at an oscilloscope and see how we can view this oscilloscope and make determinations from the wave values that it's providing for us. On the assignment, I want you to know that there's going to be 2 pages there, like 2 assignments, one for part A and one for part B, but they're only 1 page a piece. So it shouldn't be too much of a jump because we're only doing 1 day of material. So we're going to cover all of learning target 5. Okay.